Okay. So, today's the day we learn about our 3 trig functions, and there will be multiple ways that we use these. Trigonometry is the study of the ratios that exist within triangles. In basic trigonometry, which is what we cover in geometry, next year in Algebra 2, you level up a little bit. In basic trigonometry, we are only doing the study of right triangle relationships. Sorry. So every triangle we deal with trigonometry is going to be a right triangle. That is not always true for forever for the rest of time, but for geometry, we are only doing right triangles. The other thing I want to make sure that is correct in everyone's calculator is we all need to make sure we're on the correct mode. So there is a measurement of angle, so you know how you can measure something in feet or in kilometers. Angles can be measured in degrees or something called radians. Radians is just simply a different unit of measurement, okay? So we haven't learned about radians yet, but I want to make sure we're all in the right mode. So let's see if Miss Berger can actually find it. This one? No. Pause, please. Degree. Where is it? Oh, I'm such a dingus. You are right. DRG. I'm so sorry. DRG stands for degree. Sorry. We want to make sure that we're in the mode of degree and not the mode of radians. So you just make sure that you hit this DRG button and make sure that it's underlined with degree. Also, you'll see DEG, why they couldn't make it match, whatever. You're going to see DEG right here in the corner. If it's not in degrees, you will notice that it says something different. Okay? So you want to make sure that you're in the mode of degrees and that it says degrees here. Otherwise, every answer will be wrong. Okay? Okay. So the basic idea behind trigonometry is an idea of ratios. So we have already, you do not need to write this down in the back, but we have already discussed special right triangles, right? So things like a 45, 45, 90 triangle break down into this ratio x, x, x radical 2 because there is a pattern to it. Well, there is a pattern to any angle within a triangle, meaning that the sides always break down to a specific ratio. So like any 45 degree angle in a right triangle, any 45 degree angle, the opposite side compared to the adjacent side, again, you don't need to write this down, but whatever this side happens to be and whatever this side happens to be will always break down to the same ratio every single time, no matter what. And that ratio has to be 1 because they match. So any angle within a right triangle, that is true for, that the sides will always have the same exact ratio every single time. So that's the basics of trigonometry. They are ratios that are always the same no matter what the angle is. And there are 3 main ratios. The first one is the ratio sine. On your calculator, you see a button that says SIN. It still stands for sine, not sin. Oh my. All right then. Thank you for that moment. All right, so sine is the ratio of the opposite side compared to the hypotenuse. So the ratio of sine is comparing the opposite side of an angle to the hypotenuse of a triangle. Now, the hypotenuse, and we're going to abbreviate those as O and H. So O is going to stand for opposite side and H is going to stand for hypotenuse. Now, the hypotenuse of a triangle is the hypotenuse of a triangle no matter what. It is always across from the right angle. But the opposite side is relative to which angle you're looking at. Also, we don't do trigonometry on right angles. Let me make that very clear right from the beginning. We do not do trig on right angles. We are only going to be doing trig on the acute angles left over. So this idea of an opposite side is relative to which one of these you're looking at. So they're asking for the sine of A. Okay, well, the side opposite of A would be side BC. So when we talk about the sine ratio, that fraction, over the hypotenuse, we would be looking at the side BC over the hypotenuse, which is BA. But if I changed that point of view and I did the sine of B, then the opposite side would change. So the opposite side depends on which angle they're asking for, and they have to tell you which angle, okay? So before we are actually going to use trigonometry to solve for some missing side lengths, we are just going to practice finding that fraction. Okay, so all you need to know right now is that sine is opposite over hypotenuse. That's what you need to know right now. So it says we're going to find the sine of A and B. Also, I stapled my paper terribly. Oh well. B is hidden in that fold somewhere. It says write each answer as a fraction and as a decimal, round the decimal to 4 places if necessary. Okay, so the sine of A, we're going to look from A first. Opposite side over the hypotenuse. All right, well, the hypotenuse is easy because the hypotenuse is always the hypotenuse no matter what. So in this case, it's 17. And the opposite side relative to A would be which of those numbers? Good. Okay, and that's your sine ratio. So it says write it as a fraction and as a decimal. So what we're going to just quickly do is we're going to type in just 8 divided by 17. And they have asked us to round it to 4 decimal places. So we're going to round it to 0.4706. Oh, rounding facts though, right? The next number is an 8, so that's why we round it to 6. I will tell you, if your rounding skills aren't great, it actually won't make a huge difference in this chapter, so that's okay. Okay. And so where this is going to go in a little bit, we're not actually finding the angle today, but where this will eventually go is there is a specific angle measurement that has always a sine ratio of this decimal. And that's going to help us find that angle starting not this week, but after spring break. All right, the sine of B, all that's going to change is the opposite side is no longer 8. How long is the opposite side now? Okay, and then you would type in 15 divided by 17, and I'm getting approximately 0.8824, because the next number is a 5 or above. Good. So again, where this is going is there is a specific angle measurement that will always have a sine ratio of this decimal. So we'll be able to eventually find that. Now, how we're going to end up using the sine today is to find missing side lengths, not to find missing angle measurements. So it says use a sine ratio to find the value of x, round decimals to the nearest tenth. Let me stop for a second. Any questions just on the sine ratio itself? I will tell you the biggest thing today that you need to be able to recognize is you have to be able to look at a picture and recognize that they're giving you the opposite and the hypotenuse side. So for example, this first problem A, the acute angle they're giving us is this one. Now, could we subtract from 180 and get this one over here and use that one instead? Yes, but just use the one that they give you, okay? So from that angle, you have to be able to recognize, starting this week, that the parts that they're giving you are the hypotenuse. And when I say giving you, I mean like marking for you. I know we don't actually know the hypotenuse. We're going to find that in a second. But they're marking the hypotenuse for you. And they're marking the opposite side. I know it's the opposite side because it doesn't touch this angle. Okay? So they're giving me the opposite side and the hypotenuse. So I'm going to be able to use the sine ratio to figure out exactly how long this is. The way I set this up is you're going to set up the sine and you're going to use that angle measure that they give you. I don't like the way I have this set up, sorry. Okay, 53. So again, the whole purpose of trig is 53 degrees has a very specific sine ratio no matter what. So no matter what the sides are, the opposite side and the hypotenuse have to break down to the same ratio. And specifically, that ratio is that decimal. So no matter what these sides are going to be, that ratio has to equal this decimal. We'll get there in a second. So now we set up our sine ratio. Opposite over hypotenuse. It has nothing to do with x always being on one side of the fraction or the other. It has to do with the hypotenuse always being on the bottom and the opposite side always being on top. So you have to follow the ratio like it's a formula. Okay, so we're going to figure out that number, but I'm going to pause again. Go back through that. So we used the angle measurement that they gave you. Sine is always opposite over hypotenuse. So as long as you follow that formula, you'll know which number and which variable go where. Here's how we're going to solve this. I'm going to start by putting this over 1. And I'm going to type in the sine of 53. So we type in sine, that's that little sin button, 53. And it is critical that everyone is able to get this decimal. If you have one of my gray calculators, you have to actually hit the 53 first and then hit sine. If you are not getting this decimal, you need to raise your hand because I need to help you find it. Anybody else? Anybody else? All right. Shh. Regroup, regroup, regroup. You're going to write down this decimal, but because we don't want to write the whole thing down for the sake of space and time, we round it to 4. The reason we round it to 4 is because if we only round it to 1, that's going to be too much of a jump, and you're not going to get a precise answer. 4 is enough decimals to get a precise answer without it being overkill. So we're going to round that to 4 decimal places. So I'm just going to cross mine out and write 0.7986. All right, and we need to solve for x. There are a couple of ways to do this algebraically. You cannot multiply by 22 on both sides and get x alone. That's not how you would undo that. What you can do is multiply by x on both sides and then divide by the decimal, or what will always work is to cross multiply. So we get pretty good at cross multiplying. That's why I put it over 1. If you put it over 1, then you can always cross multiply. So then we get 0.7986x equals 22. So we will divide by 0.7986. And we get approximately, and the answer, I usually tell people if you round it to 1 decimal spot, that's good.
Wait, but I thought we were finding x.
We did find x. It's 20. Oh, it's not a degree. Sorry. Thank you. It's a side. Silly goose. Any other questions? Okay, I want to show you a calculator trick that someone taught me way too late in my life, and it ended up being really helpful when I got into higher mathematics. If I type in the sine of 53 and I get a decimal, and I don't feel like retyping in that decimal, there's a button right here that says ANS. It stands for answer, and it stands for the previous answer that you got. So what I can actually do without clearing this out is I can type in 22 divided by, hit second, and then that negative, and it's telling you, hey, you're going to take 22 divided by your previous answer, and then you get the same answer. So that always helped me when I got into higher mathematics because you had like huge decimals, and so it saved me time having to like retype stuff in a lot. So I just wanted to make sure I showed you that button in case you ever want to use it. All right, we're going to do it again. I'm going to do this problem down here now. Okay? So, we go from here, 41. How do you know you're using sine? Because of what they give you. We have a hypotenuse, and we have the opposite side, and I know it's the opposite side because it doesn't touch 41. So that's how I know I'm using sine. So we set up the sine of 41 equals opposite over hypotenuse. Who can set up that fraction for me? Brooklyn. Shh. Oh, just give me the opposite over hypotenuse ratio. Sorry.
17 over x.
Good. Okay, so it has nothing to do with the fact that x is always in the bottom. That was just a coincidence that they were both on the bottom. All right, now you type in the sine of 41, and we get 0.6561 technically. But I'm going to tell you guys again, like if you wrote down 6560, it's not going to change your final answer. So it's not going to be enough of a difference to actually do anything wrong. I mean, yes, you should know how to round numbers, but it's okay if you make a mistake. Yes, Devin. Okay, can you clear it out and try it one more time for me? Don't hit second. Okay, good. All right, and then we're going to cross multiply again. That's why I put it over 1, so that it makes a fraction. Cross multiply. 0.6561x equals 17 times 1 is 17. So again, I don't know if this like makes sense to, well, no, I'm not going to say it yet. I'll say it in a little bit. And I'm getting approximately 25.9. Is that right? And so I want to show you guys something. If I were to type into my calculator 17 divided by 25.9, I get a decimal that's pretty darn close to that, right? Now we did some rounding in there, that's why it's not exact, but that should always match this because I'm telling you that the ratio has to equal this decimal. Okay. Questions about the first trig function. Once you have the first one, the others are easier to understand. This is my favorite unit. I'm such a geek about trig. I think this stuff is actually fun. All right. So cosine and tangent are just different ratios. Same exact concept. Cosine is going to be the adjacent side. So that means the side right next to the angle, still over the hypotenuse on the bottom. So that ratio is going to be A over H. So the hypotenuse is always the hypotenuse no matter what. The adjacent side is relative to which angle you're looking from. So if I'm looking from angle A, the adjacent side would be the one directly next to it. So you have to be able to look at a picture and know if they're giving you the opposite side or the adjacent side. Opposite means not touching, adjacent side means right next to and touching it. Okay, so I don't want to spend a ton of time on this kind of problem because we're going to do more of this next after spring break. But let's just practice finding those ratios really quick. Okay, let's start with the cosine of A. Who thinks they feel comfortable giving me the cosine of A ratio? Devin. Perfect. So 30 is for sure the hypotenuse. 18 is the adjacent side to A. That also reduces my honor students to, someone said it, 3 over 5. Nice. And then as a decimal, that one I think is just 0.6, right? Okay. How about the cosine of B? Who wants to give me the cosine of B? Eli.
24 over 30.
Right, so that adjacent side is now different. They should never have the same answer, and that would be 4 over 5, unless it's a 45, 45, 90. Then they shouldn't have the same cosine. Oh, 0.8, sorry. Okay, so again, eventually after spring break, we get to use that ratio to figure out exactly how big that angle is, because there's only one angle that it can be. Okay. So let's go down and do a couple cosine problems. Again, you have to be able to look at a picture and decide, okay, is this sine, cosine, or tangent that I'm looking at? So I always like to put a little arc on the angle that's given because, well, first of all, the hypotenuse, I know where that's at. But the way I know if it's the adjacent side or the opposite side is if that arc goes through the side that they give me. If it goes through that side, that's the adjacent side. Like that's right next to the angle. If it's not touching that arc, that means it's the opposite side. So this one's the adjacent side. So we would use cosine. Cosine of 50 equals, who wants to finish that ratio off for me? Somebody new. I've heard from Brooklyn, though. I appreciate you. Peter. X over 10. Okay, so this is our first one where X is on top. We're going to put it over 1. This is 0.6428. Now, on this one, you can cross multiply, totally, but it's also just straight up division right here. So to get rid of division, you can just multiply by 10 on both sides. But otherwise, cross multiplying will always give you the right answer. Multiplying by 10 just moves our decimal 1 to the right, so that's going to be about 6.4. So I'll tell you guys what I was going to say, and I don't know if this is going to confuse you or not. Well, let me do one more problem, and then I'll say it. I keep taking myself back here. Okay, B, 31 degrees. Hypotenuse and adjacent. Cosine of 31 equals adjacent to 79, Hypotenuse is x. We get 0.8572 technically. Again, if you use 0.8571, it's not going to affect anything. Cross multiply. If I'm going too fast, you guys, please just let me know. I'm hoping we're following. Running out of room. 79 divided by that number is, I'm getting approximately 92.2. Is that right? And you guys can always, like, your answer should make sense, right? That makes sense to me, because if this is 79, the hypotenuse has to be bigger. You know that this has to be shorter than that side based on our properties of knowing that small sides are across from small angles, so on and so forth. Now, what I was going to say is, when I was your age, I remember discovering very quickly that, oh, if x is on top, then I'm always multiplying by that number, by the decimal. And if x is on the bottom, I'm always dividing by the decimal. So I was able to kind of skip some work shown because I was able to find that pattern. Okay, x is on top, so you're always multiplying by the cosine. X is on bottom, so you're dividing by the cosine. So if you can kind of figure out that pattern, that might speed up your work a little bit. Just my 2 cents. It doesn't actually affect anything. Okay. The last one. Tangent. Tangent is the only one that doesn't use the hypotenuse. So tangent is the opposite side over the adjacent side. So O over A. So this one you have to be really aware of which one's the opposite and which one's the adjacent. Now the hypotenuse is the hypotenuse, so that's not, like, hypotenuse is not used in tangent. It's the only one where it doesn't get used, which actually makes it, in my opinion, the easiest one to recognize because it is the only one that doesn't use the hypotenuse. So if you see a problem and the hypotenuse isn't marked, it's tangent, like it has to be tangent. It's all relative based on which angle you're looking from. So again, if you're looking from angle A, like they ask for here, opposite side is the one across from it, adjacent side is the one next to it, right? Okay. So I think if we can just get these first couple done, we will call it good. And then we have 2 days to kind of review this, and on Friday we'll do a quick little concept check before we leave for break. All right. Letter A. I know it's tangent because the hypotenuse isn't marked. Tangent of 39 equals, who can finish off that ratio? Henry Fichtel. Nice. Opposite over adjacent. I always like to mark mine too, and I'll tell you guys, I would start doing that because of where this is going to end up going. We're going to end up having to find like multiple measurements inside of one triangle, so it's smart to always label your opposite, adjacent, and your hypotenuse. Okay. Tangent of 39 is 0.8098. Cross multiply. I'm getting about 64.2. Is that what you're getting? I did not show like any work right there. I apologize. B, they didn't put the right angle box. Silly gooses. Tangent of 42. Another volunteer who wants to set up the opposite over the adjacent ratio with confidence. Owen.
I
Perfecto. Oh, that's an interesting decimal. And sometimes the rounding, you guys, is not like it's sometimes it rounds to just one decimal spot, and that's okay. This one you have a little 4 at the end. All right, times it by 19, and we get like 17.1. Again, it should always make sense because you should know like which side has to be shorter than the other. Okay. Questions. So, to the back. Actually, to the front. SOH, CAH, TOA is a mnemonic device for helping you remember the ratios. Sine equals opposite over hypotenuse. So, CAH, cosine equals adjacent over hypotenuse. TOA, tangent equals opposite over adjacent. So, sine, CAH, cosine, TOA, tangent. It is purely a little acronym to help you remember your 3 trig ratios, because you will not get to use this on your test. Probably too late to start the homework, and that's okay because we'll have some time tomorrow on this stuff. If you want to start working ahead, you can on worksheet 1. Wouldn't hurt you to get some practice in before tomorrow.